A shopkeeper sells jars of jam. The weights of the jars of jam are normally distributed with a mean of 150 grams. A customer complains that the mean weight of 8 jars she had bought was only 147 grams. An estimate for the standard deviation of the weights of the 8 jars of jam calculated from the 8 observations was 2 grams. Test at the 5% significance level whether 147 grams is significantly less than the quoted mean. We have the null hypothesis H0 where mu equals 150 and the alternate hypothesis H1 where mu is less than 150. We have n which is 8, x bar which is 147 and s which is 2. We can calculate the degrees of freedom. 8 subtract 1 is 7, so we have 7 degrees of freedom. We can calculate t with 7 degrees of freedom at a 5% significance level. If we go to the distribution application, then student t, let's match the tail correctly. We have 7 degrees of freedom, and if we change this to 5%, you will find the t value with 7 degrees of freedom is equal to negative 1.894. We can now calculate the test statistic. If we go to the statistics application, then setup, we have a hypothesis test, we have a t-test, we have a one sample t-test. We will use variable data. We have a lower tail test. We have 150. $147, $2, $8, and if we execute, we see the test statistic is equal to negative 4.242, etc. Let's now compare the negative 4.242, etc. with the negative 1.894. We see that negative 4.242, etc. is less than negative 1.894. Therefore, there is sufficient evidence to reject H0 and conclude there is evidence to suggest that the mean weight is less than 150 grams and the customer does not have a cause for complaint. A manufacturer claims that the average lifespan of its light bulbs is 100 hours. An independent testing agency believes that the bulbs may actually last longer on average. A random sample of 15 bulbs is tested, giving a mean lifespan of 103.6 hours with a standard deviation of 5 hours. Using a 5% significance level, test whether there is evidence that the mean lifespan of the bulbs is greater than 100 hours. We have the null hypothesis H0 where mu equals 100 and the alternate hypothesis H1 where mu is greater than 100. We have n which is 15, x bar which is 103.6, s which is 5. The number of degrees of freedom we have is 15 subtract 1 which is 14. We can now calculate the value of t with 14 degrees of freedom. We can do this using the distribution application. We have a student t. Let us select the appropriate tail. We have 14 degrees of freedom. We have 5%. T is equal to 1.7613. We can now work out the test statistics. If we go to the statistics application, then setup, we have a hypothesis test, we have a t-test, we will use variable data, we have an upper-tailed test, we have 100, 103.6, 5, 15, you will find t to equal 2.788, etc. If we compare this 2.788, etc. with the 1.7613, we find that 2.788, etc. is greater than 1.7613. Therefore, there is sufficient evidence to reject H0 and conclude that the bulbs last longer than 100 hours on average. A dietitian claims that a particular diet has no effect on the mean daily protein intake of adults, which is known to be 20 grams under normal conditions. A sample of 9 adults following the diet is taken. The sample mean intake is 18.5 grams with a sample standard deviation of 2.6 grams. At the 5% level of significance, test whether there is evidence that the diet changes the mean daily protein intake. We have the null hypothesis H0 where mu equals 20 and the alternate hypothesis H1 where mu does not equal 20. Here we have a two-tailed test. We have n which is 9, x bar which is 18.5, s which is 2.6. The degree of freedom is equal to 9 subtract 1 which is 8. We can calculate the value of t with 8 degrees of freedom. We can do this using the distribution application. Let's go to student t. Now here for the tail, you can either select the less than or the greater than. It doesn't make a difference because we will be using the mod of this. The degrees of freedom we have is 8. And we changed this to 0.025, which is half of the 5% because we have two tails. You will find that the value of t with 8 degrees of freedom is equal to negative 2.306. Now of course, if I change this, and then here we have 0.025, we get a positive value of t. So in other words, t is equal to 2.306. Let's now calculate the test statistic. If we go to the statistics application, we have a hypothesis test, we have a t-test, we will select variable data, we have mu which is 20, we have x bar which is 18.5, s which is 2.6, n which is 9. You will find the test statistic to equal the mod of 1.730, etc. Now, if we compare the mod of 1.730, etc. with the 2.306, you will find the mod of 1.730, etc. is less than 2.306. There is insufficient evidence to reject H0 and conclude that the diet changes mean daily protein intake. The sample mean does not differ significantly from 20 grams.